All right, everybody, good morning. Hi. Hello. I'm glad everybody's already taken advantage of the mingling opportunity that seemed to have worked. So we are really, really excited to welcome you here today. I'm Anthony Robinson. I'm from Penn State University. Amy, come on up here real quick. Amy Griffin, Arzu, Coltekin, Anthony Robinson. We've worked hard to put this together with a lot of support from our local folks at Stellenbosch University.
Who are all hiding in the back.
Yeah, who are all hiding in the back. So Kyle Logenberg and Curtis Bailey and Zhaoxu as well, and other colleagues. Jaco Kemp is going to give a talk in a little bit about this department that we're visiting today here. And before we get going on this, we should have everybody. We have quite a few people on Zoom. We're also sort of going to pay attention to the lightning talks this morning. Arzu is going to give a little introduction to kind of why we decided to put this together. And after that, we will have a short talk by Dr. Kemp about this department. And we'll go right into the lightning talks this morning, which would be a lot of fun. We have I know you've all been thinking about 5 minutes. So we have a local timekeeping device. So we will experience this.
Does everybody know what this is?
Does everybody know what this is? Yeah. So this was Amy's idea. I brought this from America. So, because I was like, how do I get one when I get there? We will definitely keep you to exactly 5 minutes. It will be a lot of fun. And we have a nice catered lunch today at the Botanical Garden. We're going to go over there for lunchtime. And then this afternoon, some fun breakout sessions where we get a little bit more interactive. So without further ado, I want to welcome Arzu Coltekin to kind of get us started.
Thanks, Anthony. Nice to see you, everyone. Actually, since you are here, you don't really need me preaching about this, but I thought that it's an obligatory opening of why we are here. We are here because AI will change the world. Let's see. Of course, yes. So, as you might have anticipated, I asked ChatGPT, will AI change the world? And it said, yes, AI is already changing the world. And then it gave me all kinds of explanations in which domains it's already changing the world: automation, data analysis, healthcare, autonomous systems, NLP, finance, education, etc., etc. Well, actually, environmental impact, etc., etc. I should not skip that part. So, as you have all witnessed in the last 2-3 years, there's a huge breakthrough in terms of the AI applications. It can now process images, language, text, speech. It creates 3D models from 2D input that was like a huge unsolved problem. It creates believable voice synthesis and so on and so forth. And it's affecting everything, and it will affect everything. Then I said, okay, what is maybe most relevant for us in the visualization domain is perhaps the generative AI. And there's all kinds of generative models. These are foundation models behind. This actually was supposed to come as animation. So many of are just familiar industry-driven initiatives. GPT is what you all know. Llama, some of you already might have also tried. Palm, Cosmos, Cody, etc. What they can do is they can also generate visualizations from data. And this is a recent paper. This is 2023 Euroviz IEEE Viz paper. They interviewed 21 people, and they took a very playful approach to it. Doom or deliciousness? Is this going to kill the whole art scene, design, visualization? What is the implications for visualizations in general? It's a very nice paper. You can have a look. And then I asked ChatGPT, will AI change cartography? What did it say? Yes, AI is already having a significant impact on the field of cartography and is expected to continue shaping its future. And then it listed automated map generation, enhancements, real-time mapping, navigation, personalized maps. That's, I think, a big deal, and we'll see a number of these today. And geospatial analysis, map interpretation. Now, that used to be an extremely difficult machine task. Now it's actually a game, one can at least get something out of it. Of course, GIS and language translation, AR mapping and crowdsourced mapping, these are listed by ChatGPT. It doesn't cover everything that our workshop covers, so we do more than that, but still. And now one other paper I will refer, and then I'll actually stop talking because the time is limited. Mapping with ChatGPT just came out. That's also a publication, in fact, and somebody tried to create statistical maps or thematic maps, and they did it a bit systematically to see how far they can go from open geospatial data sets. And this afternoon, one of the hands-on exercises we thought that we could try is in this direction. This publication is open source, and we have the link, so we can also look at it closely in the afternoon. All right, maybe one mention of a publication we were recently involved about a research agenda as well. Both Anthony and I were invited to a paper. We contributed only this much, but I will mention it. It's AI and visual analytics research opportunities. This came out in some outlet called Earth Science Reviews recently. So everything is happening and everybody's getting involved, and we are all on papers that is to do with AI one way or another. We need to educate ourselves. We need to understand the implications for our domain and our work. And that's where I'm going to stop so that we can actually move to our local hosts. Thank you very much and welcome.
All right. I think it's still working. Good morning, everybody. My name is Jaco Kemp. Let me just check my time. I'm a lecturer here in the Department of Geography and Environmental Studies. And it's my great pleasure to welcome you not just to Stellenbosch University, but to Stellenbosch, to the Cape Winelands, to the broader Cape region. I'm sure you're going to have a great time. Unfortunately, we've just missed the best of the weather. It's going to be a bit more gloomy for the next few days, but I hope you can really benefit from your time here, not just today, but for the rest of the week. Yes, okay, so we, Stellenbosch University is, depending on which world rankings you look at, one of the top universities in Africa. Our geography department is actually the oldest geography department in the country. In this talk, I'll talk a little bit about our department, and then I'll talk about the kind of teaching we do and a bit of the research we do, just to give you a bit of an overview. But yes, Stellenbosch University is a really lovely place. We're all really glad to be able to work here. Our department was founded in 1920. We recently celebrated our centennial celebrations 3 years ago. Yeah, and some of my colleagues wrote a book about the history of the department, where I got a lot of this information. Around this time, actually, Stellenbosch University wasn't called Stellenbosch University, it was called Victoria College. Then Professor Pictorial was appointed as the first professor of geography in South Africa around 1920. And for many years after that, geography was offered as a subject in arts degrees, in Bachelors of Arts degrees. Only after 1963 was it actually offered as a science subject. And then from 1970 in more the economics directions. In 1975, we established the Institute for Cartography, which is currently, it's since then changed to the Center for Geographic Analysis, which is housed in our department. I'll talk a little bit about that. And from the 1990s and the 2010s, we started developing quite a focus on geographic information technology, GIS, Earth observation, computerized mapping, which is a really exciting time. That expansion in 2010 was when I was appointed, so yeah, very happy about that. Our department, we are administratively actually located in an arts faculty, but as many of you can, of course, appreciate, geography is by its nature extremely interdisciplinary. So that was an arbitrary decision that was made historically. We find ourselves actually uncomfortably in this domain because we have a strong science and computer science and mapping component, but geography is about this interplay between humans and their environment and how we perceive it. But yeah, so we're in an arts faculty. We've got 3 broad focus areas of sort of expertise in our department. One is on human geography and Included in that is sort of urban geography and tourism and things like that. The second one is the more physical and environmental geography. And the third one, where I'm involved, is geoinformatics, which is where all the GIS and the computer stuff happens. We also have two centers inside our department. The first one is CRUISE. It's the Center for Regional and Urban Innovation and Statistical Exploration, which is a tongue twister. But yes, so they bring the urban planning and urban and regional science component. We also have the Center for Geographic Analysis, which started as a sort of a research unit, which it still is, but it now does sort of contract research and internal research and a bit of consulting, largely driven by machine learning and satellite Earth observation and things like that. We're quite a big department. That's all our happy faces. I'll quickly, just in case you are interested in connecting with any of us on any of these sort of domains, quickly, I didn't even have time to put in the name, so you will just have to Google us and find who you're looking for. But quickly, the human geographers, who've also recently formed a small town research unit, is Prof. Ronnie Donaldson, Professor Gustav Visser, and Professor Manfred Spockter. Our physical and environmental geographers is Dr. Suzanne Grenfell, Dr. Samantha Williams, and Dr. Jan de Waal. Yeah, we don't have time for me to tell you everything about them. I've got Lodien Willemse. This is CRUISE, the Urban and Regional Science people. This is Lodien Willemse, Dr. Aniela Horn, Dr. Herman Geyer, and Dr. Dani Duplessis. Wow, to remember all my colleagues. So these are all the people who do the urban and regional planning science. The geographic information technology cluster is quite big. We're 7 people. That's Prof. Adrian van Niekerk, Prof. Helen de Klerk, myself, Dr. Jaco Kemp, Dr. Zaan Manch, who's sitting over there, Dr. Eric Bashimbie, Mr. Karl Lochenberg, and Curtis Bailey, who's in the back there. So yeah, that's us. Then the Center for Geographic Analysis is managed by Mr. Garth Stevenson. He's got a team of people. They've got a fairly high turnover. They tend to appoint students that come through our ranks who work there for quite a few years and then sort of use that as a launching pad. At the moment, that's Theo Poe, Jessica Eichhoff, John Duplessis, Kaylee Higgs, and James Cupp. So they do real fantastic work. They are developers and cartographers and things. And then we have our administrative staff, Catherine Liedemann, Deirdre Davids, and Yvette Recki. So that's quickly how we all fit together. I hope that gave you a bit of an idea. In terms of our teaching, again, got a bunch of boring slides about what we teach, but maybe it's interesting for you. I couldn't even, there's no time for us to really go into the content, but to give you an idea of the different degrees in which geography or geoinformatics is connected in our department. So in terms of our undergraduate, and again, we here split a little bit between the science and the arts. So on the more social sciences side, our flagship program there is a Bachelor of Arts in Development and Environment, where geography is the major, usually the major. That is the degree that usually leads into our postgraduate stream. But we also, geography is also an elective in BA Humanities and BA Sports Science and a few other degrees. And these are some of our undergraduate students doing their things. On the science side, we've got our flagship there is the BSc Science. Oh, hello. Please mute yourself on the other side. Bachelor of Science in Geoinformatics. But we also, again, our geographic information technology modules are electives in computer science and mathematical science. A lot of people from biodiversity and ecology also, of course, find a lot of value in being able to map things, earth science similarly. And we have a newly established Bachelor of Data Science, which has a focal area of geoinformatics as well. So we serve all those programs. Then when we go to postgraduate, which I think the rest of the world just calls graduate, but yes. Again, on the social science side, we have I'm not sure how common this is in many other countries. We've got what we call an honors degree, which is sort of the fourth year of study. It's actually a separate degree. So we usually do a 3-year bachelor's degree followed by a 1-year honors degree. And that is required to be able to get into a master's. So you can't go directly from a bachelor into a master's. So we have this degree, Bachelor of Arts in honors in geography and environmental studies. We've got some master's degrees as well, masters in geography, masters in GIS, masters of urban and regional planning and urban and regional science. And then we've got PhDs in all of those as well. So that's obviously where we specialize. Again, on the science side, we've got honors degree in geoinformatics, as well as geography. This is a recent creation as well. We realized we had started to crowd GIS into this really heavily computer sciencey direction and not made it available as postgraduate direction for geographers in general, or physical geographers, for example. And then we have our masters and PhDs in geoinformatics and geography as well on the more science side. How's my time? 1 minute. So in terms of the research we do, those sort of focal areas give you a bit of an idea of the areas in which we focus. I made a bit of a list of the things I'm aware of that we work in our department. There are surely other things that other people or my colleagues are working on. This is my list. But quickly, the urban planning and small and regional towns, urbanization and tourism access is quite strong. Then on the more environmental side, we've got really good research happening in groundwater quality monitoring and mapping and wetland management. We have people working in that same vein also on mapping and understanding biomes and ecotones and wildlife corridors. Southern Africa is a wonderful place for wildlife conservation, and there's lots of efforts to try and map and understand and reconnect fragmented parts of land. And then, in terms of the more geospatial things, the guys at the CGA and some of our colleagues do a lot of work on agricultural mapping of crops and understanding and predicting their water use, land use change, digital soil mapping and terrain mapping, hyperspectral imagery. Kyle at the back there works with precision viticulture. We're in the winelands, so we constantly have to keep an eye on what's where. Myself, I work a lot on radar remote sensing. I say the radar remote sensing artificial intelligence, but technically AI is happening almost everywhere here. And Curtis in the back there has a specific interest in the effects of climate change. So yeah, that's our broad areas. I've got a few pretty pictures, but we probably don't have time. This is a project by one of our urban geographers on art washing. It's a community project on using art installations to get communities involved and talking about gentrification. This is Suzanne's work on wetland monitoring. That's Gustav's work on tourism and urban change. These are in every single irrigated and non-irrigated agricultural land in the country that we mapped as a pre-step to determine how much water they use. South Africa is a pretty water scarce country. Agriculture uses 60% of all our water. So we need to know where they are. So that was a big project that happened there. Okay, I'm going to skip a little bit ahead. You're welcome to contact us at any time you want. Obviously, you are here, you know where we are. Google us, you'll find on our website all the people I showed. You'll get email addresses if you're interested in chatting with us or connecting. That will be great. All right, thank you. And I will see you around for the day. Enjoy the day. All right, cheers.
All right. I'm just gonna skip to my first slide. So we basically innately know what is a map. It's obviously Google Maps, but even when a map is of a fictional place, we can kind of innately know that is a map. We have, of course, famous maps of fictional places like Tolkien's Middle Earth, or lesser known places. This is a map by my student Max Johnson, who came up with this fictional place, Odethia, and made these beautiful fictional maps. But when we try to ask AI as it exists right now to make a map, we end up with a lot of nonsense. I was inspired by a talk that Anthony gave at the University of Oregon, where I'm at, this past semester, where he showed some of the outputs from the AI system, DALL-E 2. I'm sure somebody else is going to talk about that, so I'm not going to go into the system. Basically, you pay $15 for the ability to, quote, create realistic images and art from a description in natural language. And I asked it to make a map of Oregon, which is the state I live in the United States on the West Coast, with exact labels for each county. And so it can't really do that very well. Of course, this is contrasted with when you ask Google to spit this out, you get something that's very much what we expect. I even kind of asked it to do some more specific exact labeling. Labeling was really the thing that I kept noticing being quite a disaster. I mean, the shape isn't right, but whatever. But I tried to prompt it a bit more with asking it to write in English, and it still is not a language that I know. So, anyways, all right. I was surprised about this because when you ask, say, ChatGPT, which is like all under this OpenAI system, it can really easily give you the labels that you might put on a map. So there's all these, disclaimers on ChatGPT, but it very easily prints out the counties of the state that I live in. You can even ask it the centroid and the latitude and longitude, and it gives you that fairly accurate information as text. So this got me thinking about this idea of the map sandwich. So I worked at Esri. I'm a professor now, but I worked at Esri between 2011 and 2014 before I went back for my PhD. And I was working a lot on base maps during that time. And the term map sandwich was really kind of all the rage at Esri. And basically the map sandwich was this idea that the reference layer is stored as a separate layer from the base map data. And even though these are both rasters, they operate not as a single image, but as different layers. You then can stick your thematic layer in between. So you have your base map, your thematic layer, and then your labels on top. And of course, this is really similar to kind of how we think about GIS and have thought about GIS for a long time as these separate sets of layers. And maybe AI should be trained to think about maps as different layers as well. So the image on the left is just from Ian McCard's Designing with Nature, which is kind of the beginning of really thinking about these different layers kind of overlapping. And explicitly calling for map overlays. The image on the right is what I give my students in my intro GIS class. I give them transparencies, which totally confuses all my colleagues. They're like, why are you printing out transparencies? But I have them kind of learn how to do different geoprocessing things away from a computer, which is nice. Okay, so this brings me to my last slide, which is that I think maybe AI could be improved for mapping if labels are stored as a separate layer that's made of text, and if the graphic of the base map information could potentially be stored separately from the thematic data, and then a way to kind of georeference these layers together, even if the place isn't real. Thank you.
Okay. Hello, everyone. I'm Zhaoxu. I'm a master's student at University of Oregon, also a reference map cartographer. So we all know that AI is not ideal for just like directly generating the reference maps, but I'm here just want to talk about my experience of using AI to assist in my atlas making. So we all know that one atlas is composed of different sections, such as this one's mainly the thematics maps in the front and the reference maps in later. That's like a typical structure of an atlas. So such as the Times Universal Atlas of the World, we have this kind of thematic map pages in the front and also the reference map pages with different sorts of descriptions on the side. And for some ones, even like this one, the DK Concise Atlas of the World, we have like a really rich content with different graphics, charts, maps, and other stuffs, you know, even for the reference maps too, it looks really beautiful and informative. So when I was making my atlas, it's just like there are two major difficulties that I have encountered. The first one is like, I don't speak really good. Maybe I speak pretty good English, but I don't have enough power or courage to writing in like such a huge amount of descriptions describing the places I mapped. Also, I didn't go through any professional graphic design training. So I used those two types of AI, the text AI and the graphic AI, to help me to go through this whole processes. So for the text AI, I just use ChatGPT, you know, like I gave chat an identity. Just imagine you are an editor of an atlas, and we have to attract more visitors to buy our atlas. Answer gotcha. Okay. So after giving AI an identity, I just use that AI to generate description for me. And it turns out it's pretty good at describing different places or give a list of different travel attractions around the city. And how's the correctness or preciseness of the ChatGPT describing the things? I just tested with six different short distance attractions around Seoul, and it turns out five out of six are pretty around the Seoul. So it's actually pretty good at explaining. With only one, the last one, Zhaoxu National Park, is pretty far away. So I extensively use AI in my Atlas projects, such as those right square parts. I use the ChatGPT to help me to generate the descriptive text describing the maps I made. But there are also some shortcomings of the ChatGPT because such as I have to give me 150 words introducing Tokyo. That's definitely not 150 words. So I ask it over and over again, that's too short. That's too long. So yeah, so sometimes I have to modify by myself. Also, there are some frequent repetitive descriptions with ChatGPT generations, like laid-back lifestyles, and also some accuracy and correctness issues with ChatGPT. I have to check it. So make sure to always review it and check the correctness of the AI generations before using it. Second one, graphic AI. So I asked Midjourney, oh no. So I asked Midjourney to help me make an infographic about the world population migrations because I'm not good at thematic map making. I'm a reference map cartographer. So this is a result it gives me, a topic about the world population and migration, an infographic. It's beautiful, right? So how can I use it to my own map making? How can it give me inspirations of making maps? So I focus on different visual elements of the generations. First, you notice this kind of skyscrapers, something like this, relief. Maybe that representing the population densities, the ribbons, maybe resembling the migration routes. Also, these beautiful graphics. So I try to convert those elements in AI generation to the map that I actually make. In order to make that, I have to make several compromises. So for example, these ribbons, I cannot really let it show here. Sorry. Okay. So I had to make compromises, and this is the final project that I made. And we can compare that. It's similar, but it's totally different. There are several risks of using AI, so we have to make it consistent throughout pages and also be careful about attributions. Okay, that's all. Thank you for your attention.
Welcome to our presentation, Stable Diffusion in Cartography, Opportunities and Challenges. My name is Raimund Schnürer. I am a doctoral student at ETH Zürich. My dissertation is about storytelling in 3D maps. Luckily, I'm close to the end. In a previous work, I had a look at how to create 3D counterparts of human 2D figures appearing on pictorial maps using artificial neural networks. In one of the stages, I denoised pictorial faces and reconstructed some details using an autoencoder. Besides autoencoders, research mainly focused on generative adversarial networks in the past years, but it seems that diffusion networks become more popular nowadays. Here an example of an image generated based on a textual input using a stable diffusion model by Midjourney. Another popular tool is DALL-E, but there are many more image generators and editors available. For our experiments later on, we will make use of these two open source frameworks. But how does it actually work? During training, Gaussian noise is added to an image and gradually removed by Stable Diffusion. The process is conditioned on encoded text or other inputs. The denoising steps are performed in a unit with cross-attention layers in latent space, while the image is outputted in pixel space. Most Stable Diffusion models are trained on the Lion 5B dataset, which consists of more than 5 billion images and corresponding descriptions, mostly in English language. You can explore the dataset on this website. As you see, also images of maps are included. After covering the basics, it's high time to show you our experiments. Since it is related to my dissertation, we first tested whether existing Stable Diffusion models can assist in creating pictorial maps and objects. Out of the box, random pictorial maps with certain features can be generated. A plugin enables to in-paint areas with specified objects, which interestingly seem to match the style of the given map. Alternatively, real-world objects can be simplified and cartoonified, and afterwards placed on a map. Next, we examined whether we can train a model to generate maps in a specific style using two historic Swiss maps as an example. By a technique called textual inversion, we try to introduce a new term for each style, which is denoted in italics. For a start, we trained the model with just 12 map tiles, and we got some quite interesting results. Using this small sample, it is even possible to combine the new terms with existing concepts. We now increased the number of map tiles to 800, leading to very similar styles. However, there are some inconsistencies in symbology and topology, such as roads crossing a lake. Also, the generated labels consist mostly of cryptic letters and numbers. Unfortunately, a combination with other terms were not possible anymore, as seen on the previous slide, due to overfitting. As the generation process can be initiated with given images instead of random noise, we tested whether we can transform one style into the other. However, this was only partly successful. In a second experiment, we tried to guide the generation process by additional segmentation masks. We applied an add-on called ControlNet, which required some more memory on the GPU. Again, during training, some quite fancy intermediate results were produced. After training the control net for several epochs, results close to the original map tile were produced. Nevertheless, some random elements are generated on empty areas, possibly due to mismatches between mask and images, such as contour lines. In summary, Stable Diffusion is suitable for many cartographic applications, but it requires some computational power. Appealing results can be achieved, however, semantics may be incorrect. The output can be steered into a desired direction, yet more intuitive editing possibilities are needed. Future research may investigate the potential of generating 3D and animated maps. Thank you for your attention.
Morning, everyone. My name is Leigh, and today I'm just going to give you a brief introduction to how we are utilizing deep learning in a variety of ways to create geospatial data at our company, LuxCarta. So just an intro to me and where I fit in. I've been working at LuxCarta for the last 7 years. I'm a research and development engineer, and I'm also a part-time PhD student here at Stellenbosch. And my PhD thesis also involves a couple of themes to do with deep learning, specifically around large-scale national land cover mapping. So LuxCarta is an international company, and we generate geospatial data, and specifically raster and vector data, including 3D data. So our clients need this data in order for them to do visualizations and types of cartography. We're kind of the data engine. And our main clients fall within the telco industry as well as the visual simulation market. And over the last few years, there's been a definitive transition on how we used to generate data with more traditional machine learning approaches to now very much deep learning focused methods across all of our data pipelines. And a catalyst for that really was in 2018, we got a project where we were required to produce 100,000 square kilometers of 50 centimeter data at really high specs. So down to individual tree crown polygons with height information and individual building footprints with height information as well. And we needed to do it within 3 months. And so that really kickstarted our use of deep learning across all of our methodologies. I'm going to show 3 brief examples of our AI-generated data. Firstly, feature extraction. So that's the actual land use, land cover data that we're producing. Then also an example of how we generate synthetic terrain. That's more in the visual simulation market. And then finally, just an example briefly on our global 10-meter mosaic, which uses also very much deep learning focused methods on how to produce that. So for feature extraction, we have trained in-house deep learning models based on huge archival data, and we've generated really robust generalizable models that are useful on any type of source imagery, whether it be satellite or aerial, and it produces high quality and very detailed features like building polygons and tree crown polygons. And a development of this has also been a service that we supply to our clients where they have used through a web API called Brightwith On Demand, where they can actually input any of their own source imagery, and our models will do on-the-fly or real-time data extraction for them. And the quantity, the scale, and the quality of the data that we have to produce for clients would not really be possible, I don't think, without really relying on AI-generated methods. Then within the synthetic terrain generation realm, this is really for the visual simulation guys. So not only are our features generated using deep learning, but the way in which we do texturing and real-world representation also relies heavily on AI. Specifically, how we generate roof shape and colors and how we extract that information from satellite or aerial imagery, very much AI-centric. We do this not just for buildings, but also other land use, land cover layers or data. And this visualization, I think we all understand, is becoming really, really important in how we visualize our real world and interact with it. And then finally, another example is what we call our Bright Earth product. So this is a 10-meter global base map based on Sentinel-2 imagery, which is nearly entirely cloudless. We use deep learning to do cloud detection and cloud masking in the mosaicing process, as well as the way that we have generated land use, land cover globally, using this mosaic as a starting point. We're now also starting to implement deep learning change detection on imagery so that we can start real-time or work towards real-time updating of not just the land use, but also of the mosaic itself. So I had to do that really quickly and very high overview, but I have listed all published articles relating to our AI work. So if you are interested in a little bit more detail on the data and methods, yeah, you're welcome to go find those. Thanks.
Okay, so good morning, everybody. My name is Standa Popolka. I'm from Olomouc, from Czech Republic. And today I will tell you something about AI and cognitive cartography. In our department, we are using eye tracking for evaluation and optimization of maps. And since the first article about eye tracking and cognitive cartography, it's 50 years this year. And during the time, many approaches how to analyze data emerge. And we are mainly focusing on qualitative analysis using sequence charts. And we develop some software for calculation of similarities among Kemp of different participants. And we are using two softwares. First one is Scangraph that I already told you, and I presented many times since 2016. And we got brand new gaze plotter for creation of the sequence charts. And on Monday, my colleague Michaela will have a presentation about that. So you are welcome there. And I will move to use of AI. So let's imagine that you have a map, and some people look at the map and do there something, and we want to analyze how they did it. So we can divide the map into areas of interest and visualize using Michaela's tool, visualize these sequences. And then now we can interpret what happened, how much they look into the map, how much they look into the legend, how often they switch, etc., etc. And I tried to ask ChatGPT-4 to interpret this data. So this is input data for each participant, sequence of fixations according to areas of interest. And AI told me something like that. I think it's pretty nice. It found some how it was after they look into map, then into the legend, and then back, etc., etc. But it's necessary to check all the informations. For example, like here, P18 spent whole time in a map, which is not true. And I asked it to calculate some numbers, so how much time they spent in each area of interest. It's almost okay, but again, some information is not very true. But it is interesting that it tried to find some importance of correlative symbols with their meanings. Yeah, so to try to interpret the way how the people looked. And then I asked to find some participants with similar strategy, and the answer is something like that. So they a group of those who focus on a map, a group of those who balance focus on map and legend, etc., etc. And finally, I asked to quantify the similarities according to Levenstein distance, which is the way how we use it in Scangraph. And finally, the AI told me that it can't calculate it, so our software is still useful. And the humans win. So to conclude, I think it might help to interpret data because it do a lot of work, but it's necessary to check all the answers because of you can't believe everything. And final message: don't forget to attend the presentation of Michaela about gaze plotter. It's really cool and it works with I think 3 or 4 different eye trackers. It's open source and everything. Thank you. That's all.
Hello, everyone. So I'll talk about like where Estanda actually left. I will pick up from there about like personalizing map reading using AI and eye tracking. And I will actually talk about the importance of benchmark data sets to be able to do so. So with the increasing amount of eye tracking data collected everywhere, we need to find like analytical and methodological ways to analyze this data and use it for instance, predicting user behavior and personalized maps in terms of its design and content, and anticipating users' intention with relying on data. And how we can train machine learning algorithms to learn patterns and relationship between various factors influencing our visual attention and the map use behavior. And then we compare this data with user demographics or task objectives to predict how different users or tasks will influence their attention on maps. And using this output of these predictive models, we can adapt the map design in real time and interactively based on the user. And why? Because this collected eye tracking data has a great potential for the development of these novel and interactive interfaces, which can aid our map users in navigating maps, personalizing the user experience of map reading, and also enhancing the effectiveness of spatial decision making, especially for non-experts. But to be able to do so, we need data generated during the observation of maps. There are so many standardized data sets for eye tracking, but they are not actually for maps. And this is our pain because we don't have open eye tracking data sets collected during map reading. And we can use some traditional salience models, but they are designed to predict visual attention while observing the natural images. They are very simple images, but maps are more than that. They're very complex, and those salience models cannot perform well when it comes to maps, such as an artificial, complex, and abstract representation of the real world. So we published a data set from my PhD research. It's called CartoAI, and you can access it through this QR code. It's published on Harvard Dataverse. So it includes the full description of the data set with the full procedural details, area of interest, all map stimuli and fixations. We think that it would kind of benefit for the researchers who will work in the same thing. And we also published a paper. One of my co-authors is here, Arzu. If you are interested, you can read that. And also together with two researchers who are working on EEG and fMRI, we also sent a paper to location-based services about this open benchmark data sets in neuroscientific methods, not necessarily eye tracking, but also with EEG, fMRI, GSR, this type of neurofeedback. So what can our community do? Actually, I would like to pay attention that we could revive this remote eye tracking benchmarking exercise, which was initiated by Amy here. And we can actually prepare a detailed documentation guidelines for sharing eye tracking data openly and maybe creating a platform, because this was discussed through many years to create like a common pool for our user experiments, similar to MIT, but with a cartographic focus and compatible, of course, with fair data sharing standards. But I think the most important take-home message here is like encouraging ourselves and everyone else to share their experimented data within or outside our communities. For instance, DataViz, InfoViz, UX, any type of communities that are outside of cartography, because it really ignites this interdisciplinary collaborations, especially with researchers with same problems. For instance, in my last project, I collaborated with a computer scientist who created an open source eye tracking analysis tool, which I will be talking about on Monday. Little promo. So yeah, so I would like to hear your ideas. And if you want to reach me, you can reach me through here. Thank you very much.
Yes, good morning. Unfortunately, Mona cannot make it. But my talk kind of nicely connects what we have heard before. And as many of you might know, I'm particularly interested in mobile maps for quite some years. So my interest is in how AI can be used sort of to improve these mobile maps. So today, I mean, this is kind of mobile maps are a commodity. They're pre-installed on our smartphones. But I would argue, if you look at these examples, there are just a few, that they in general look very much similar. I mean, there are nuances in style, but actually they just follow up the classic traditional map style, and they are kind of general purpose maps, compromise, and they're, at least I would argue, non-personalized. And that's where maybe AI can come into play. We in our community know for quite some time and do more and more research on that, sort of on the diversity of our map users. For long, maybe we have assumed they're all the same, but of course we know there are many individual differences, skills, abilities, and so on. So now we could sort of acknowledge that and try to sort of adapt maps, personalize them to these different abilities, cognitive styles, context, and so on. And I just put some elements here. So if we have the data, the information available about context, about we can source sort of user states, abilities, and so on, and could use that sort of to adapt the content of mobile maps, the style, and the interface. And AI, I would say, maybe we'll see other examples, but I haven't seen too many yet where we really see that this is happening. But of course, it is just a question about when and how it will happen. So, of course, AI could use all sorts of sort of modeling. It could model the user behavior. It could infer context information. It can use machine learning somehow to categorize. It can be involved in planning, decision making, not just in the map making itself. And this could then be potentially used to personalize these mobile maps and the use. Now, what we have seen examples before, I just did a quick research to say, and I also let ChatGPT produce some from the land, for the description of the land, please make me a map, or down there, it's similar to what we've seen before. Well, it resembles somehow the Stellenbosch or Cape Town area, but not much more. There might be better things out there, but for the particular case of personalizing mobile maps, I haven't seen from my little research so far. My main question now, I haven't applied AI myself, but I just tried to raise a few questions. We might discuss them afterwards. If this is going to happen, or maybe it's happening soon. So what are the implications? How should this combination of them, the mobile map users, map makers, traditional cartographers, and AI, how should that work? How can the users be kept in the loop? We'll hear more about trust, I think, later on, but this is sort of a general question. How do mobile users trust in such maps? But one question that sort of I was thinking about, how is the difference, or what would be the difference between a human cartographer and a machine cartographer, an AI produced? Is there a difference? Why should be one better than the other? Well, I don't know. And that relates to many questions like, can AI, for instance, better or worse judge the quality of source data to be used for mapping? An ethic question we'll hear more, but one is sort of, could it be that AI introduces even more biases than thought, and how explainable can sort of modify, adapt the mobile map be? Can this be explained to a user? How can this process of adapting a mobile map be transparent to the user? And last, maybe this is a bit far stretching, but I was really thinking, okay, if we know that maybe AI can create its own reality, and for now we have with reality, or we perceive as reality, and then the human map maker kind of makes an interpretation, abstraction, and then transforms it into a visual representation. Well, what is if AI generates its own reality and then abstracts it in a mobile map? Is this somehow, and can we tell the difference, or where is this sort of getting blurry? So there are just a few questions where I would think we need to, as a community, take care of, because as I said, it's just a matter of time probably that this will be possible. But can we do and can we influence it? And maybe I can make a little, just the last advertisement on Monday, Amy will present a research agenda where some of these questions are also covered. Thank you very much.
Maps with eye tracking.
Thank you, Anthony. I'll try to keep to my 5 minutes, although others have made very good job in giving for the last speaker as well. So I thought to give a few words about our recent project, where we took a glance on how to combine eye tracking with artificial intelligence on data. And despite this broad title that we have, I'm mainly presenting the idea of a 2-year project that we finished last year, and Marve was part of the project. And we tried to develop a model and idea of assisting geo-exploration of maps, mainly with eye tracking aid. Creating a loop, basically, which would study how a person is looking a map, and then knowing by the data all the objects of the map to refine the map in a loop to a personalized way, in fact, for the person to understand the map better, or then also to find new aspects of the map. And from those experiments, I don't go at all more into detail, but well, naturally, as we know by our own experience and our user studies, highlighting map features certainly changes the way users look at the map. And the case falls on the highlighted features. But what was interesting that in large amounts, and this is something that we hypothesized that it could be so, that actually these participants also looked very much on areas that had not highlighted and that had not been watched earlier. So we could guide the case of looking that map. And also saw some lightening of the cognitive load of map watching in there. So this is kind of the lightnings in a figural sense, and the idea was to combine the automatic real-time analysis of eye tracking top there, and then bottom in this figure AI selection of geo features from geo data, and combine these two viewpoints, so the viewpoint of the machine, so to say, and the viewpoint of the person read by the eye tracking, and select new highlighted features from the map to show to the watcher. This is a workflow designed for creating this kind of application. Basically, how as explained already, but then maybe more about the future ideas and how then this could be applied in continued efforts. So first of all, this understanding unknown geodata, that was our main take in this project due to the setting of the project. But then also we could help people reading complicated maps with these personalized devices. We could facilitate searching particular topics or even objects or features on the map. We could help them directing gaze to correct places on a map, depending on the task. For example, navigators, people, we don't always look at the correct place in the first glance. A steering map view might be something a little bit more to the interactive development, and then also other image types might be considered for this kind of personalizing than maps. Well, I'm the last speaker. I could make this video play about the last idea, and I guess maybe the sound will arrive soon. But this is what we thought. So, person looking at the map, then the analysis software analyzing it and showing the person what actually he or she was looking, because, well, as we know, for example, this kind of topography maps are complicated to read and people often have difficulty in reading. So a couple of acknowledgement and publications, one in Finnish, but AI can translate really well, so I was courageous enough to put that Finnish text also in this slide. And then thanks a lot for your attention.